This is Star Talk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. My day job, I'm the director of the Hayden Planetarium at the American Museum of Natural History right here in New York City. This is the Cosmic Queries edition, which I do not do alone. I need help. I've got Chuck Nice.
Hey, Neil.
Chuck Nice comic right here with me in studio.
That's right.
Calling from the internet. Questions. This is not a themed Cosmic Queries.
This is our potpourri.
Potpourri. I don't even know how to spell that. Potpourri.
A veritable grab bag.
Grab bag, a smelly grab. Potpourri is smells, right?
Yes,
Yeah,
yes.
Okay. So this is whatever was left over in the bag after we pulled out the questions.
A smelly grab bag of Star Talk Radio.
It could be themed. Well, let's get right into it.
Yeah,
now,
man.
I haven't seen these questions, so
That's right.
if I don't know something, I'm going to tell you.
There you go.
Okay.
And guess what? That's one of the best things is that you're kind of shooting from the hip on this one.
Yeah,
but
totally.
But you never really shoot from the hip, you know, because you know what you're talking about.
All right.
So here we go. This is from Harry Dassori. All right. Subject matter, dark matter.
Dark matter, sure.
All right. Get ready for this.
By the way,
will you?
there was a chapter of my memoir
Right.
called Dark Matters.
Yes. There's a chapter of my life called Dark Matters.
Just saying. We each have some dark
We all know
matter.
everybody's got some dark matters going on. All right. Here we go. Let me finish before you freak out. Okay?
I'll go.
I've witnessed ghosts and several experiences that have made me a believer in the supernatural, or what some would call spiritual existence.
And whose question is
this? Is from Harry Dassori.
Harry Dassori. Okay.
Okay.
Gotcha.
My question to you, Neil, is can the expansion of dark matter in the universe be the accumulation of souls of all the planets in the cosmos? Some speculate that soul has weight or a value of weight. Impossible to prove?
Okay. Well, so where shall we begin?
Yes,
So
I don't know.
He wants to connect his personal experiences with ghosts
Yes.
with the dark matter in the universe.
Right. So what he's saying is these apparitions that he has experienced, clearly they must have some type of mass or weight. Could dark matter actually be the accumulation of all such apparitions as the ones that he's experienced?
All the souls. Okay.
All the souls.
So a couple of things. Let's tackle souls for the moment.
Okay.
All right? Back when X-rays were discovered by Wilhelm Röntgen, who's a German physicist. In fact, he won the first Nobel Prize in physics in 1900 for his discovery of X-rays. Soulful people of the day said, if X-rays can see through matter and through the human body, maybe if we X-rayed a body that was dying, we'd be able to see the soul leave the body.
What?
I know. There you go. And so they attempted these experiments, and nothing. They didn't see nothing.
Right. Thank God the person was already dying. Exposing them to all those X-rays like that.
And in a rare moment, we're thanking God for someone dying. Right. Okay. All right. So first there was that. All right. Second, the instant you die, which has a fuzzy. We don't really. I tweeted recently, the next person who is brought back to life after being pronounced clinically dead, it seems like we need to start redefining what dead is. If you keep coming back because you were clinically dead,
right.
Maybe clinically dead really isn't dead. All right.
True.
Right. So the point is, there was some movie called 23 whatever. Remember this movie?
Yes, I know what you're talking about. 23 ounces or some crazy
Yeah, 23 grams.
23 grams.
21 grams, right. It's just BS. If you're alive and then you're dead and you're on a scale, your weight doesn't change. All right?
Gotcha.
Unless you evacuate your bowels and it spills off the scale onto the floor.
Right.
Okay? Plus, most people don't know how much 21 grams actually is. Do you know how much it's like the weight of a nickel? I mean, it's not very much.
No, it's not a lot at all.
It's not a lot at all.
Right.
So
I know because of my past use of cocaine.
Because drug dealers were metric long before any American got involved. How many grams?
Whenever I meet somebody who knows the metric system, I'm like, you've done a lot of drugs, haven't you? Or you sold them.
So the point is, when you die, you have way more than that of just leftover leftover urine and bowel contents. So, and your sphincters relax and it all comes out of you, right? But if you're not careful about how you make those measurements, you could be led to think that you weigh less at death than you did it alive. But so anyhow, if it's soul in terms of the mass of the soul, if you want to believe there is one, there's no evidence that it has mass.
Right. That's number one.
We know approximately how many people there have been ever born. It's about 100 billion, plus or minus.
Okay.
So 100 billion times any number is really, no matter what number you're multiplying it by, it's going to be small compared with the mass equivalent of the dark matter of the universe. Right. Now, he's saying the souls of all the planets. So he's going to have to believe that there's life on other planets that has souls.
Correct.
And so it's the sum of all the souls. And there's no evidence for that. Now, one of the things science does that nothing before science did was establish something that is objectively true. So if I say, I saw it, it's real. Well, was it in your head or was it actually real?
Right. What are the qualifiers of seeing?
Exactly. Science allows us to distinguish something that's happening in your head from something that is objectively true that everybody can agree with, as well as apparatus that we have built to make the measurement.
Correct.
So what he needs to do is find the ghosts, grab them, put them in a net or something, bring them to the lab, or get more than himself as witness to these ghosts.
Correct.
Then we can start making measurements. Until then, we kind of have to sort of I'm left saying that it's all going on in his head, and therefore we don't have to explain cosmic forces that affect the birth of the universe based on what he sees out of his own head.
Right. So basically, in the corporeal world, Harry, you are out of your mind.
No, in other words, just to be fair to his question, he may have surely been seeing ghosts.
Right.
That doesn't mean the ghosts are objectively real. That's all I'm saying.
Right. Exactly.
The human mind is a complex place. We still don't understand.
We still don't understand.
A whole new field called neuroscience is being born as we speak.
To determine why we see these things.
To try to handle these things.
Right.
So I'm not saying he's not telling the truth about what he believes he saw.
Exactly.
But whether it's an objectively true thing is a whole other thing.
It could be true. It could just be his truth based upon his drinking of mushroom tea. The LSD is what made it true.
Or if he hasn't and he does, that would take it a whole other notch.
Exactly.
You're listening to the Cosmic Queries edition of Star Talk Radio. I'm here with Chuck Nice Comic, tweeting at Chuck Nice Comic.
That's correct, sir.
You got it. Star Talk Radio. We tweet as well at Star Talk Radio. And find us on the web, startalkradio.net. We'll be back in a moment. We're back. Star Talk Radio, Cosmic Queries edition. Chuck, you just reached to the bottom of the barrel and you just got whatever was left over. So we're calling this the potpourri?
The potpourri.
All right, let's potpourri
Or as
this.
you put it so eloquently, the smelly grab bag of Star Talk
When
Radio.
I think of potpourri, it's the stuff that smells nice and you put it in the bathroom where stuff otherwise doesn't smell nice.
That's true. That's true.
You don't put potpourri in a rose garden.
So true.
Right. So, okay.
Now you sound like a philosopher. Not an astrophysicist.
That is. You'd never put potpourri
No
in
one puts potpourri in a rose garden.
Okay.
Then I hear like Chinese chimes, you know what I mean? Just like, snatch the pepper from my hand, grasshopper. But, that's awesome.
Go.
All right, here we go. Adita Patil is...
I have to say, you're the worst pronouncer of names I've ever had opposite me on a table. I'm just saying.
Listen, Neil, I am not going...
Somebody has to call your stuff out.
Listen, I'm glad you're doing it because I am awful.
Okay.
I got to admit, I'm terrible at this, all right? But Aditya, okay, whatever. Adita Patil says, by the way, she wants you to know that she is 16 years old. And she also wants you to know that she is from India. So we are worldwide, buddy. We are worldwide.
There you go.
Okay. Where does all the energy go when it's all over is her subject matter. You've said, Mr. Tyson, Dr. Tyson, in many episodes that the universe is going from chaos to order and would finally reach a state of 0 Kelvin. My question is, where does all the energy go? All the kinetic energy that is present now, what happens to it?
Okay, I don't think I've ever said we're going from chaos to order. I don't
believe you've ever said that either. I think you've always said that the universe is in a state of extreme disorder.
Disorder and becoming more disordered. But she knows that where temperature is dropping in the universe to and approaching, there's a mathematical term for it, asymptotically approaching absolute zero. When you're asymptote to something, it means you get ever closer to it, but will never actually reach it. Until you reach infinity.
Kind of like fractals.
Yeah. There's always detail all the way down through, and it's never going to stop.
It's never going to stop.
Right. So it's not exactly like fractals, but the idea that you're hitting some infinity point,
right,
and then it stops.
Yeah, that's the only thing I could relate it to in my tiny little mind.
All right. So you say, where's the energy? The energy's still there. It's just more and more and more diluted until it's so diluted that it's effectively zero energy density in the universe.
Okay.
So we talk about energy density. Normally we use the word density, we think of matter density. So lead is more dense than paper, right? And so it makes good paperweights, although we don't use lead anymore, and nor do we even have paperweights. You know why we don't have paperweights?
No.
Because we don't have fans inside of offices because we have central air conditioning.
Yes, which is exactly why the register above my desk keeps blowing the papers off my desk. Sorry.
Does it seriously?
Yeah.
All right. Well, whatever it is, it's less than what a fan would have done back in the day. So here we have the universe expands, temperature drops, asymptotically approaches absolute zero. Okay. It's the density of the energy that continues to drop.
So the energy doesn't go anywhere.
It's the total energy is the same.
Total energy is the same.
Correct.
It's just diluted to the place where it is effectively zero energy.
It is so dilute, just go home. Okay. So that's what's going on there.
Yo, that makes
And by the way, the opposite would be true. In a collapsing universe, the energy density would be going up. And the universe would be getting hotter and hotter and hotter over time.
Okay.
Yeah, that'd be a
bad thing, though, right?
Yeah, I'd rather end in ice than in fire.
Okay, cool. Well, there you go. That's a great answer. Good question. All right, this is from Mark Fenimore, calls himself the chemistry nerd.
Ooh.
Okay, here it is. Dr. Tyson, in a freshly brewed cup of coffee, if a freshly brewed cup of coffee was placed into a pressurized, help me out here, adiabatic container and exposed to the vacuum of space while being shielded from the sun or starlight, how long would it take for said coffee to freeze? What is the mechanism for energy transfer in this case?
Well, if it's not exposed to the outdoors,
right?
Well, what you'd have to do is expand the volume. It's in a cavity, and if you expand that cavity, the energy has to now dilute, and there'll be a point where it dilutes so low that then you freeze what's there. So that adiabatic is a physics term, a chemistry physics term that refers to whether you keep pressure constant and change the temperature, or keep the temperature constant and change the pressure when you're doing these experiments.
Gotcha.
And so, by the way, if you just had a canister there and if it was completely insulated, the temperature would never change.
Right.
But you cannot completely insulate something because there's always a molecule of something attached, communicating with the one adjacent to it, and either with light energy or with vibrational energy. So it's going to cool down no matter what.
Okay, so the fact is that even if it were completely insulated, the fact is you can never completely insulate something.
Yeah.
Is that what you're trying to tell me, Dr. Tyson?
Right. So, yes, that, as well as if you want to sort of expand the volume, because there'll be pressure in there because it's a warm cup of coffee.
Okay.
If you try to expand the volume, what will ultimately happen is the energy density will drop.
And then at some point, it will actually freeze.
Yeah, if you keep doing that, yeah.
Right.
Yeah, you can drop it so low. But maybe you'd have to evaporate all of the coffee before that happened, and then it's gaseous, and then the concept of freezing no longer matters. So as material changes state, it's a fascinating thing, actually, that we don't spend enough time on in school, I think. Then just think about it. Here's this water, and then you drop the temperature, then it becomes solid.
Right.
A liquid becomes, imagine if you had never seen ice. Just imagine. I mean, there were people who grew up in the tropics,
Exactly. Never saw ice
in their life.
That's right.
And then you just take water, put it in some some cavity, and you pull it out, and it's solid. They're not even going to believe you.
He has magic.
If physicists never told people how we do stuff, we would just be people. We would be the gods of our culture.
True.
Because we would have powers that they think were divine.
Exactly. You know what? It's so funny. As a quick aside, there is a great show for kids, and it's really trippy, but it's called Adventure Time. And there's a character. She's a scientist, and she is constantly railing against the people of the kingdom because they believe in magic.
Okay.
It's awesome. That's great. All right. There you go.
What else you got?
Let's move on to Jeremy Zucchero. Okay, I got that one right. Jeremy Zucchero.
You can at least try to put a little Jeremy Zucchero.
Zucchero.
Yeah, there.
Zucchero. Okay, there we go.
The most interesting man in the world. Jeremy
Zucchero.
Go.
Okay. Could intelligent life have evolved on Earth in the distant past? There seems to be little evidence to support this idea, but would there be? What are the odds that this would be missed in fossil evidence? And is there physical reason why this could not have happened?
I think about this all the time.
Do you really?
Yes.
Okay, cool.
I lay awake at night thinking about this question.
Okay, cool.
Because what I do is I ask if civilization ended today, how long would it take, given the earthquakes and volcanoes and other geologic forces on Earth, how long would it take for every trace of our civilization
to be just gone?
Completely gone, being sucked into the magma of a volcano and coming out as a fresh rock.
Right.
All right. So jump-starting the geologic record. And I've spoken with some geologists about this. It would be billions of years. It's not...
Oh, okay.
Yeah, it's a while. Because you have to get every bit... We're everywhere on Earth, not basically. Right. You have to get every bit of landmass deep enough down so that it's completely wiped out.
Right.
And melted down and reshaped into the next
because the Earth is literally remaking itself.
It is
over time, right?
Yes, it is. And it has to be sort of uniform enough so that there's no trace. So I said, could there have been an intelligent civilization in the past? And I think not. I think not. First, because it would take a long time to completely wipe them off the map. Second, complex life is an evolutionary trajectory.
Gotcha.
You would not have had single-celled life forms 3 billion years ago popping into a multicellular intelligent life form overnight, making a civilization, then disappearing again. You have to track it through the growth of complexity in the evolutionary chain. And when you do that, you only get sort of big-brained, if intelligence derives from big brain, you only start getting big-brained mammals after the dinosaurs are taken out of the picture.
Gotcha.
And that was 65 million years ago.
Right.
Our mammal ancestors scurrying underfoot, trying to not be hors d'oeuvres for T-Rex. Only when T-Rex got taken away did our mammal brain start getting big and become anything that we call intelligence today.
Gotcha. So now, when you look at that trajectory, is what you're saying that the Earth has not been here long enough for that trajectory to have taken place in the past and then been wiped away record-wise so that we are finding ourselves in that place again today?
It's a combination of not only that, you would not expect complex neurological organisms, or organisms with complex neurology, to have been around long enough ago, given the time it would have taken to create such a creature.
Gotcha.
As the evidence of the fossil record shows.
Fantastic.
So there you have it.
There you go, man. That's a great answer.
When we come back, more of Cosmic Queries Potpourri Edition. You're listening to Star Talk. We're back on Star Talk, Cosmic Queries Edition. Potpourri. Chuck, why? You're the one who dug all these questions out of the bottom of the barrel because they didn't fit any other category. There's a question about whether there's past life on Earth. I want to add something to that.
Go ahead.
There's a lot of science fiction storytelling that has sort of aliens helping out our civilization.
Yes.
You know, like Stargate, for example.
Stargate.
You know, the pyramids came from some...
well, aliens who came down, helped us build it, and then left.
And then
for some strange reason. Just like, hey, we need to go build some pyramids on Earth.
On Earth, in that spot.
In that spot, and then we're out of here. That's their sole purpose of coming here. These humans look like they need pyramids.
Yeah, and they're not mechanical or anything. They're just
not
stone.
at all. Just stone buildings that we are going to, because we're that technologically advanced. Let's give these people some stone triangles to drop in the middle of a desert, and then we're out of here. Okay.
Yeah, so that I couldn't. That's what I was going to say. No, so the urge to think that ancient peoples could not have actually done these great structures. I mean, the fact is they have the same brain that we do.
We do,
right? And so they have less technology, but they're not any less smart.
Right.
In fact, some could argue that they're smarter.
Absolutely.
So I'm always upset when we want to credit some intelligent aliens for stuff that our own species did here on Earth.
Exactly.
Give us some credit, man.
It's funny because, my son, who's 7 years old, and he said, well, how come, if they didn't have anything technical back in the day, they could actually create these great buildings and things, but yet we don't seem to be as smart as they are. And I went, because they didn't have cable television, son.
Exactly.
That's why.
And they had 100 years to build it.
Right. Exactly.
There's none of this. Oh, look, we got to get this done by October.
Right.
No.
Exactly.
Pyramids is like take whatever how long it takes.
Right.
You're
Lifetimes and nobody cared. Right. We got number time. That's
right.
great.
All right, what else you got?
Here we go. This is from our very own somebody here in New York City, and Andrew Wood. Andrew Wood.
And you pronounce his name correctly.
Yes, I did. Thank you, Andrew, for having a very easy to pronounce name. All right. We have several impact craters on Earth from meteorites. My question is this. We have the big holes, but where did the big freaking rock disappear to?
Ooh.
I will not be able to sleep until I know.
Oh, I like people who can't sleep because science keeps them awake. That is good. So a couple of things. Probably the most famous hole in the ground is in meteor hole in the ground is in Arizona,
right
near Winslow, Arizona. In fact, I was just there filming for Cosmos.
Oh, cool.
Yeah, cool. Okay, you can't not go to the crater.
Right.
It's almost a mile across. And
now, is this the crater that they say may have wiped out everything? Is this the big...
No. This one, it was a bad day in Arizona when this thing hit.
Okay.
Or whatever it was called back then, 50,000 years ago. Then there's another crater that was found submerged under the Gulf, found primarily by the efforts of oil drillers trying to find out the gravity anomalies, because if it's oil or is it sand, is it sediment, and they found this ridge. And this ridge is the rim of a crater, and that's the one we trace to the dead dinosaurs.
Gotcha.
And that hit near the Yucatan Peninsula, near what is now Mexico. And I once gave a talk, and I said... but I said, near what is now Mexico. I said, but that's not what the dinosaurs called it. And someone in the front row said, yeah, they called it Mexico.
That's actually funny.
It's Spanish fluent dinosaurs. So, yes, we do have these craters. In the Chesapeake Bay area, we now know from space is a meteor impact. So, meteor impact created Chesapeake Bay.
Look at that.
Yeah, right there in Maryland.
All right.
So there you have it. So what happened to the rock?
What happened to the rock?
That if the speed of the asteroid, which is true in every case, is higher... So you have a speed and you can calculate how much energy it has for motion. We call it kinetic energy. Kinetic is motion. So write down that number, okay? You can calculate that.
Right.
Now you say, what's this thing made of? Is it rock? Is it metal? What's holding it together? Are there bonds? There are chemical bonds from one atom to another. There's this crystal lattice. There's some forces holding the thing together.
Right.
Add that up. Write down that number. If the kinetic energy number is bigger than the number that's holding it together, poof, and the thing hits, where did all the kinetic energy go? Back into the object, and it explodes, vaporizes, goes to smithereens. And so, in fact, most of it essentially vaporizes.
Gotcha.
And that's called a high-speed collision, and that's what happens. That's why you have fragments scattered, but the bulk mass of the asteroid is gone. Now, if the thing came in slowly, it would just hit and bounce, and then you get the whole...
And the rock would be sitting around.
In fact, meteor crater was purchased by a metal speculator because he presumed that the huge object that made the crater is still buried beneath.
There.
Yeah, so he had he bought the land, brought out his metal detectors, drilled boreholes, didn't find a damn thing.
Oh.
Yeah, poor guy.
Because he didn't have your formula. All he needed was your formula. It would have saved him a lot of money. Now this dude is just like every dude you see with black socks and sandals on the beach with his little metal detector.
So it's the Barringer family, and they actually still own the land, and so now it's a tourist attraction, and they're making money off of tourists.
Okay, well at least he got his money back somehow.
Somehow. Mm-hmm. So so that's what happens in a high speed impact, and if those two numbers were different, the object would basically stay in one piece.
Right. So there's your answer, Mr. Wood. Look for the rock in the land of Smithereen.
Exactly. You're listening to Star Talk Radio, Cosmic Queries Potpourri Edition. We'll be right back. We're back, Star Talk Cosmic Queries Potpourri Edition. Chuck Nice.
Hey.
You reading me these questions? I haven't seen or heard any of them.
That's right. You have not seen them or heard them, but I have them right here.
Go for it.
Okay, let's go to John Reitzka. Reitzka. Okay, you know it's John. I'm sorry, John. So, okay, subject of the tides, and this is kind of something that we've touched on.
Oh, me and tides go way back.
Yeah, you and tides.
Me, just
you
back up.
You are the veritable prince of tides. See what I did there? Did you see what I did there? Okay.
I thought it was the king of tides, but okay, fine.
Okay. I've heard Neil mention in multiple episodes that the gravitational forces of both the moon and the sun combine during a full moon to create the highest tides on Earth. It seems to me that they should cancel each other out, being that the masses are on opposite sides of the Earth. It also seems that the highest tides should be during the new moon because the moon and the sun are both on the same side of the Earth. I could look up the answer, but I just love hearing Chuck Nice's take on the questions.
Did he really say that?
He did really say
that.
Oh, my God. All right. So, listen, basically what he's saying is when the moon and the sun are on the same side, is there a greater pull?
All right, so here we go. You ready?
Go ahead, please.
All right. So let's forget the sun for the moment.
All right.
Well, let's just have Earth and the moon. The moon raises tides on Earth.
Gotcha.
And there are only two things that affect that. The mass of the moon, which isn't changing.
Right.
And the distance the moon is from Earth.
Right.
Those are the only two things that can affect the tides that the moon raises on Earth.
Okay.
Now, the moon's orbit is not an exact circle. It's like a flattened circle, an ellipse is the official term. You can think of it as an oval. And so occasionally the moon is closer to the Earth. It'll have raised slightly higher tides. Occasionally the moon is farther, raised slightly lower tides. And that has nothing to do with what phase the moon is. The moon's tides on Earth are the same for every phase, from new moon crescent, first quarter gibbous, everybody.
Because the moon is the same size.
The moon is the same damn thing in the damn sky.
Right,
okay?
right.
All right, so now, bring in the sun.
Okay.
The sun is trying to raise tides too. And it's a function of how far are we from the sun and how much mass the sun is. It's trying to do this on us too. But it turns out its strength of tides is only about a third as strong as that of the moon. It turns out, because it's so far away.
So far away.
And distance makes a big difference with tides.
Gotcha.
Because the tidal strength varies as the cube of the distance.
Gotcha.
If you're math fluent, you got that.
I know what you're saying.
All right.
So it is directly and proportionally tied to the distance.
Yes.
Okay.
To the third power of the distance.
Power.
All right.
Right.
So if you're far away, it's way less than if you're nearby.
Gotcha.
So now watch. If the moon's tides align with the sun's tides, you have high tide. Higher than at any other time.
Gotcha.
If the moon's tide is at right angles to the sun's tides, they're each trying to bulge at right angles to one another. That's where they cancel out.
Gotcha.
Okay? That at right angles. And I think they call it the neap tide, all right? You'll still get a slightly high tide, but it's not as high as at full moon or at new moon. And here's how the tide works. You ready? Okay. So you have the moon and you have Earth. Mm-hmm. The moon is pulling harder on the side of the Earth closer to the moon than it is at the middle of the Earth. And it is pulling harder at the middle of the Earth than it is pulling at the far side of the Earth.
Right. Okay.
Because it's farther away.
It's farther away. Because it's, like we said, it's distance.
It's the distance.
It's the distance thing.
Thank you. And so now you are a squishy pool of water. The side of you closest to the moon is being pulled most. And the side of you farthest from the moon is being pulled least. So all this gets stretched out. That's all it is. It's a big stretching game.
Gotcha.
And by the way, the solid Earth has tides as well. But that doesn't manifest as because it's a solid thing that's changing. But we see and tides are never come in and out. The bulge is always there in space, and it's Earth turning inside the bulge. So in fact, when you
sounds so dirty. Oh my God.
So if you're on the beach, you say, "Here comes the tide." No, the tide was there in space, and you are on Earth being turned into it. Into the bulge of the tide.
Wow.
I know. So now watch. So the moon stretches out the water, near side, far side.
Right.
The sun stretches out the water, near side, far side. So on new moon or full moon, everybody's lined up, everybody's stretching it out. There you have it. It's all just stretching.
It's basically a love triangle between the sun, the moon, and the water.
However, when the triangle is at its finest, it makes a straight line.
Ah.
Yeah, that's where you want your highest triangle.
That's the highest triangle.
I mean, the highest bowl is the straight line triangle. That's right.
All right, here we go. Amputees in space from Jeff Lowe wants to know, hey, just curious to hear your thoughts about whether amputees in space would do well, since there's less muscles to atrophy. I'm also curious to hear if there would be effects from zero-G on organs. After all, the heart is a muscle, but it's constantly working, even in space.
Yeah, so amputees in space, you're not walking anywhere. So, in fact, the space walk, you're not walking. It's called space floating.
It's space floating.
So, in a way, you don't really need your legs. So, amputees, I think, would do very well space walking. Your organs are sort of suspended in your body. They're not loose to float around and get out of alignment if you go into zero-G. Plus, when you lay down horizontally, your heart does not work against gravity. It pumps blood horizontally, and that's like it not working against gravity. So your heart would be just fine in space.
Okay.
But it was not obvious. In the early days, we didn't know whether you could swallow in space. Does your saliva know to go down your throat? Turns out your body does a good job pushing liquids wherever they got to go. Next. Go.
This is from Joe M. Space suits to simulate Earth gravity. Oh, no. I don't want that one. Take that back. Here's one. How about Adam Caspi? Your biggest fan in Israel. That's what he said. Okay. From my limited understanding, nothing can travel above the speed of light. Why does light travel at exactly that speed? I understand that it can't travel faster, but why not slower? Even a small amount, like 2 meters per second.
Light does travel slower when it goes through anything other than a vacuum. Ooh. Oh, snap.
Yo, Adam.
Light goes slower when it enters our atmosphere, which is why when you see sunrise, it's not actually risen yet. It is still below the horizon because when it changes medium, this light slows down and it refracts, showing you the sun before it is actually risen. Light is at its slowest through diamond. It only goes 40% as fast as its speed in a vacuum through diamond. That's why there's all this internal reflection in your ring, and it looks radiant because the light internally reflected multiple times before it came out, looking like the diamond itself is giving you light. Oh, thank you.
Well, there you go. Yo, that was hot. That was hot.
Yeah?
All right, here we go. This one from Luke Schlonigan.
Luke, yes, go.
Luke. Aliens. On your aliens episode, you said aliens the size of a solar system couldn't exist because it would take too long for a signal to travel from one point of the brain to another and for the alien to react. But what if it did not have a centralized brain? What if the decision-making capabilities were spread throughout? In other words, a couple little brains around that alien head.
No, okay. I didn't say life could not exist. I just thought it would be really clumsy form of life.
Gotcha.
If it stubs its toe. It would take 10 hours to respond to that fact. Or if something starts eating it, it won't know until it's way too late. It's just not an effective size to be life. If you're competing against the speed of light for you to communicate signals across your body. If it has regionally controlled centers, brain centers,
right,
then is it one organism?
Oh, snap!
There you go.
Oh.
I question whether it is in fact one organism.
Luke, there's your answer.
Okay. Welcome back to Star Talk. We are in extended Cosmic Queries edition. Chuck.
Hey, Neil, that's
what do you
right.
have for me?
All right, let's, you know what, since this is an extension, why don't we start off as we normally do?
Wait, is this themed or is it galactic gumbo?
I don't know.
Is it gumbo?
I think we're going to do the gumbo.
We'll do the gumbo, okay. Galactic gumbo.
Guarantee.
All right, what do you got?
Little there. Maybe we'll have a little etouffee with that.
Etouffee. I love etouffee cosmos. All right, what do you have?
All right, here we go. This is a Patreon patron, Kyle Yoakum, who says...
Once again, because they paid money to be first in the question list.
That is correct, because...
How crass of us.
That's right.
Okay.
We are not above being whores. All right, here we go. Kyle says this, Dr. Tyson, if Isaac Newton, wow, that's your man, too.
That's my boy.
He went for your man right
there. Bring
me
anything.
There you go. He said, if Isaac Newton was to see us today and all the science that we have discovered since his passing, what discoveries might he be most interested in? And what specific areas of study would you guess he would want to continue working on?
Believe it or not, I think about this all the time.
Get out.
All the time. At least weekly. At least weekly.
Wow, Kyle, look at you.
I think of Isaac Newton as a dinner guest. And then, but then it gets real, and then it's like, okay, that was a bad idea. Okay? Okay, so Isaac Newton walks in.
Okay.
I say, Isaac, would you like to bathe right now? Okay, first of all, because back then, there was no, okay, I'm saying, okay, all right, so we get that out of the way.
Right.
Okay, so then I say, would you like to go for a drive? A drive in what? I said a car. I said, well, what's a car?
Right.
So then I say it's a horse-drawn carriage
without the horse.
And they say, well, how does it operate? Well, it operates on energy. Well, what's energy? Energy was not formally defined at the time of Isaac Newton. That would take another 100 years before we understood energy. Well, where do you get the energy? We get it from liquids. What kind of energy is in that? Chemical energy. How do you get, what is chemical energy? Well, it's bound in the molecules. What's a molecule? This would just go on and on and on and on and on and on. There's energy bound up in the molecular state. What is, and it would take, well, he's a fast study, don't get me wrong,
right.
But you can't just ask him a modern question, because then I would show him my iPhone and his head would explode, okay? I would show him the calculator on the iPhone, where he could have then spent seconds doing what he took years calculating.
Right.
Okay?
Yeah.
In his life. And that's just one app on the iPhone. And so poor Isaac, I need a psychiatrist with me just to help the guy out.
And wait till you show him porn on your phone. Oh my God!
No, actually, he was. He never married, and as far as we know, had no meaningful amorous relationships, and was mostly misanthropic. Yeah.
Oh, really?
Yeah. So he was probably asexual.
Yeah, most likely asexual.
Yeah.
Well, no wonder.
Yeah.
No wonder.
When he had energy to
I was gonna say, no wonder he discovered all this stuff. Oh my God! It was just built up sexual frustration. That's
all pent up.
It's all pent up.
Got to discover calculus.
Exactly.
What are we going to do with this energy?
I need to calculate a way to get laid. No. Oh wow.
Yeah. He never married. Never had any close male or female friends.
Wow.
Yeah. There were some letters he wrote. Some people might think he might have been gay, but. Nonetheless, even if he was gay,
he still was
not. He was not, the man of the night.
Yeah,
right.
Exactly.
But so anyhow, so there's that. But let's catch him up to speed. I would say I would hand him the dark matter and dark energy problem.
Right.
I say, look, dude, we've been at this for 50 years. Fix it.
Go ahead and
solve this.
Knock it out, buddy.
Knock this one out.
Knock this one
okay?
out.
Here's a pencil. Here's a paper. Here's a computer. When you figure out how to use a computer,
Right.
go have at it. Okay.
That's super cool, man. Hey, what a great question,
Yeah.
Kyle. That was really cool. And the answer is, in modern times, Isaac Newton is a dumbass. Okay. No, I'm joking, of course. Wow, I like the dark matter idea. That's cool.
Dark matter and dark energy.
Yeah. All right. Let's go to Stephen Humphrey on Facebook, who says, what does that crazy-looking globe on Neil's table depict?
Oh,
yeah.
Well, I have this globe that might be sitting behind me where I'm seated right now.
Right.
This is a brass globe.
Right.
That is sculpted by Paul Manship, who is the same guy who sculpted Prometheus, who oversees the skating rink in Rockefeller Plaza.
Center. All right. Yeah.
Yeah. So, and in fact, if you look at the base of this globe, there's a recumbent figure which evokes the recumbent Prometheus at Rockefeller Center.
Right. Well,
so this globe is a perfectly spinning, functioning globe, and it has all 88 constellations in Art Deco relief.
Oh!
Etched onto them.
Wow.
Yeah. There are two, as I understand it, there are two in the world. One is owned by, was it Akers? I forgot his first name. The former CEO of IBM.
Okay.
Who paid for an exhibit where this appeared.
Right.
This was on the exhibit floor of the Hayden Planetarium 40 years ago. In fact, I remember it when I came here as a kid.
Wow.
Yeah. But now we're not about constellations anymore. But it's still a brilliant work of art, and I get to put it in my office.
Nice. Wow, what a cool. Hey, Stephen, thank you for that. Man, there's only two of those globes in the world, and you have one of them.
I have one of them. Well, I mean, the museum. I don't own.
Oh, it's in your office. It's yours.
And of course, I can tip this. This tips on angle. And
right.
So it's a mechanically functioning sphere.
Fantastic. All right, let's go to. This is Chava Bello.
Oh, just to be clear.
Yes.
This is 1934, so Art Deco was a very
big deal.
prevailing thing at the time.
Very much so.
Yeah.
Especially here in New York, when you look at all the architecture here in this city.
Chrysler
Building, yes. Great many.
Rockefeller Center itself.
Absolutely. The whole place. Very cool. Let's see this. From Instagram says, do you foresee space hotels, oh, come on, with green hookers? Really? Come on.
Green. So this would be not just interspecies sex. We're talking about inter-life form sex.
Exactly.
I don't know. I mean, people... Usually the first thing that happens with a new invention is people try to figure out how to have sex with it.
That's so true.
And so I will not preclude this as a thing that could one day happen.
Right.
And clearly this derives from Captain Kirk.
I was going to say
Captain Kirk.
Kurt beat you to it.
This is in the 1960s.
That's
Somehow it was okay
Yep.
for Captain Kirk to be banging green aliens.
That's right.
Okay? And it was always what is kiss? Oh, it's an old Earth emotion that we show when we have affection. Oh, let's do that again.
Exactly.
And then they kiss again, and then it fade to black, and they go to the next scene.
Right.
So he's getting some alien.
Alien
booty.
That's right.
So I don't see why not. I mean, if we have a fully if all life forms are visiting at the local bar, like in Star Wars? Like in Star Wars bar, why wouldn't it be?
Yeah. I'm not going anywhere, anything green, okay? I'm going nowhere. If it's green, I'm staying way away from it. That's all there is to it.
It could be that it undergoes photosynthesis and never has to eat.
Wow, that'd be
interesting.
Really, yeah.
Think about it. Just think about this, Chuck. Okay.
I'm thinking about it.
If you are not a plant on this earth,
right,
then you have to kill something for your own nourishment.
That's right. Other than that, you got to eat something else, right?
No, you have to kill something,
right,
for your own nourishment.
That's
if
true.
You're an alien where everybody's getting their energy from their local star, and they come to Earth, how barbaric we would look to them.
That's true.
Think about that.
Yeah, and if they're green, I'm not having sex with him.
Regardless, okay.
All right, here we go. Juan Garcia from Facebook says.
Juan Garcia.
Juan Garcia. What a great name. Did the meteor that killed the dinosaurs hit hard enough to spread life around our solar system? Wow. So would the debris
Yes.
or the detritus have escape velocity?
Yes.
Get out.
Yes.
Is that real?
Yes.
Oh, my God.
Did you call it detritus?
Detritus, yes. Why?
Oh, okay.
Is that okay?
I think more of flotsam and jetsam. But
Oh,
that's fine.
Look at you.
That's fine. That's cool. We're cool. We're cool.
All right.
So, if you only know flotsam and jetsam from the Disney movie The Little Mermaid. Flotsam is stuff left over after your ship was torpedoed.
Right.
That floats. And jetsam is stuff that you threw overboard so that you tried to not have that fate.
Exactly.
Right. So, yes, so that asteroid would have easily thrust Earth rocks with enough velocity to achieve to escape Earth.
Wow.
And so here's the thing.
Go ahead.
Here's the thing.
I'm listening.
The moon doesn't have weather. It doesn't have plate tectonics.
Right.
The moon is a record of anything that once hit it.
Right.
There may be Earth fossils
On the moon.
from before we had good fossils to get a record of what was happening here.
That's super cool. That is super cool.
Yeah. So it's called panspermia, and so life may be more similar than we might otherwise think.
Interesting. So, then that begs the question, is it very possible that the life here on Earth was seeded from some other cosmic entity?
If we were, it would likely have been Mars, which means all humans are descendants of Martians.
Ooh.
Yeah.
I like that.
Because Mars was wet and fertile before Earth was. And don't go there, Chuck. Okay, so before Earth was, I saw your facial expressions.
I know.
Okay, so if there was any life transfer, panspermia, it would have been from Mars to Earth.
Okay.
Initially. Yeah.
Oh, that's cool, man. That is super cool.
Mars had running water.
Right.
You know.
Yeah. Wow. Hey, Juan Garcia, what a great question. All right, let's go to Liam.
Last question.
Oh, okay.
Okay, good.
This is Liam Chromatic World Leverford.
That's a name? Okay.
What a name. Liam Chromatic World Leverford from Facebook says, I've heard that with the James Webb Telescope that is supposed to be be the next step up from the Hubble, that we could potentially see the Big Bang. But I haven't been able to explain this to anyone because I really don't understand it. Please help.
That's a good reason
Yeah.
for not being able to explain something.
So how would you see the Big Bang?
No, not with this telescope. You
Right.
would see what this will enable us to do is specifically tuned to detect galaxies being born just after the Big Bang.
Right.
Right now, our telescopes aren't sensitive enough or tuned properly to see those that phenomenon. So those galaxies are emitting copious amounts of blue and ultraviolet light.
Okay.
But that light is coming from such a distance that the expansion of the universe has redshifted that light deep in the red and infrared part of the spectrum. So the James Webb Telescope is tuned to the infrared
Gotcha.
to see light that started out as ultraviolet
Oh.
in the formation of galaxies. We are ahead of, isn't that?
That is phenomenal.
It is. We are there.
That's genius.
It is, and by the way, it can also see things that just happen to be giving infrared light,
Right.
like star-forming regions of the galaxy and this sort of thing.
Nurseries. and that kind of
Nurseries,
thing.
exactly.
Right.
Exactly. Newly born hatcheries. But yeah, but it's not designed to see the Big Bang itself.
Oh, cool.
Yeah.
Oh, man, that's fascinating.
Oh, yeah.
All right. Well, thank you for that
Chuck,
question.
I think we ran out of time.
Oh, man.
Oh, okay. We got to call it, but that was good. Actor Gumbo edition
Oh, that's
extension.
Right. There you go, that vibe. Guarantee right now.
Guarantee. I'm Neil deGrasse Tyson. I've been with Chuck Nice. As always, we bid you